Hello everyone, myself Pranjal Sharma. This is the third video on the topic scalars and vectors. Those who have not watched my previous videos, please watch them. I have added the link of these other two videos in the description. After watching those videos, you will understand this video properly. And today we will mainly focus on how to solve numerical problems by using the concept we have learned earlier. So before solving numerical problems, we have to learn some concepts which I have not covered yet. So today, at first, we will learn the square of a vector. Square of a vector. In my previous video, I have told you that how a vector can be written in terms of its components. Suppose a vector A, so A can be written in terms of its components like this: axy, axi, ay, z cap, az, k cap. So in my first video, I have defined scalar product. Scalar product of two vectors. Suppose A and B, then their product should be magnitude of A, magnitude of B, cos of theta, where theta be the angle between A and B. Now, if I make dot product of A with the vector itself, that is A dot A, then according to this definition, we can write magnitude of A, and here cos of angle, that is the angle between A and A is 0 because both are identical. So again, magnitude of A is A, magnitude of A is A, and cos 0 equal to 1, so it is A square. So A dot A equal to A square. Now, in my previous video, I have also told that how we can make dot product by using component. In this case, A dot A can be written as AXI plus AYZ plus AZK dot AXI plus AYZ plus AZK. In that video, I have teach you how we can make dot product. Here, the final result of this dot product can be written as here AX into AX, AX square, AY into AY, AY square, AZ into AZ, AZ square. If you want to learn more about this product, please watch my previous video. That is the part 2 video. So AX square, A dot A equal to AX square plus AY square plus AZ square. Again, we found that A dot A equal to A square by comparing these two expressions, A dot A equal to A square and A dot A equal to AX square plus AY square plus AZ square. We found that it can be written as A square equal to AX square plus AY square plus AZ square, or A is equal to square root of AX square plus AY square plus AZ square. So this is the expression of square of a vector. We can use this expression for any vectors. Suppose we consider a vector, we consider the position vector. In my previous video, I have told you that the component form of position vector can be written as r equal to xi plus yj plus zk. So the square of the square of the vector can be written as x square plus y square plus z square, and its magnitude r can be written as x square plus y square plus z square. So this expression give the square of the vector, and it give magnitude. So this gives magnitude, and this gives square of the vector. Okay. Now we have learned square of a vector and also learned how we can calculate magnitude of a vector if we know the component of those vectors. Now, how can we convert a simple vector to a unit vector? That means converting a vector to unit vector. So what is unit vector? Those vectors which have unit magnitude in a specific direction. Now suppose A is a vector, so A can be written as AXI plus AYJ plus AZK. So we can write its magnitude such as is A is equal to square root of AX square plus AY square plus AZ square. So any unit vector A cap can be calculated by this formula, vector A divided by its magnitude. So magnitude, this is similar to, that is equal to is actually equal to this, magnitude of A is equal to A equal to this. So any vectors can be converted by using this formula. So vector here A equal to AXI plus AYJ plus AZK divided by X square plus AY square plus AZ square. So this is the expression of unit vector. If we consider any ordinary vector, then we can convert it into unit vector by using this formula. Now, in my first video, I have told how we add two vectors. Suppose A and B are two vectors. Then we can add them by two methods graphically. One is triangular method and another is parallelogram method. Here we will again revisiting the triangular method. So this is A and B. So how we, or triangular method also known as head to tail method. So here, how can we add two vectors in triangular method? We just write this vector in the same manner as in here, and other vectors, just put the other vectors into the other vectors head into the tail of B. So A is head on the tail of B. So the resultant vector in this case in the direction of this, which is A plus of B, and this is also known as resultant vector. So R equal to A plus of B. So R is a resultant vector. Here R is resultant vector. So when two vectors are in the same plane, then we can add two vectors by triangular method, R equal, and we get these results. Similarly, we can subtract two vectors I have discussed all these things in my first video. Please watch that video. Now, how can we calculate the magnitude of R? Since R here, R is equal to A plus of B, R equal to A plus of B. So, here, what we have learned here, calculating the magnitude of resultant vector. So R equal to A plus of B. So now R dot R equal to A plus of B, A plus of B. Since we know that A dot A is A square, similarly R dot R equal to R square, equal to here A dot A plus of B plus B dot A plus of B, or A dot of A plus A dot of B plus B dot of A plus B dot of B, or A dot of A plus, since we know that dot product, all vector dot products are commutative, that means A dot B equal to B dot A. This is known as commutative property. Commutative property. So A dot B and B dot A both are similar, so we can write twice A dot B plus B dot B. So A dot A is again A square and B dot B equal to B square, right? Now 2, again dot product of A dot B equal to simply magnitude of A, magnitude of B, cos of theta. So R square equal to A square plus B square plus twice AB cos theta. So simply R equal to square root of A square plus B square twice AB cos of theta, where theta is the angle between A and B. So in this way we can calculate the resultant of a vector. Similarly, we can calculate the resultant vector for R equal to A minus B. In this case, when R equal to A minus of B, then if you calculate in a similar way, you will find R is equal to square root of A square plus B square minus of twice AB cos of theta. So these two formulas are very, very important for calculating the magnitude of resultant vectors. Now we will recall some important formulas what we have learned so far. So any dot product of two vectors A dot B equal to magnitude of A, magnitude of B cos of theta, where theta be the angle between them, or A, B cos theta. And again in component form, A dot B can be written as AX BX plus AY BY plus AZ BZ. We can calculate cross product of two vectors A cross of B by simply writing them in determinant form AX BX, sorry, AY AZ BX BY bz. So I equal to, in this case, this is a, we have to ignore this row, so ay bz and az by. Again we put negative sign. So why I have put here negative sign? Please watch my second video, that is part 2, where I have explained these things. Here z can equal to ax into bz minus az into bx plus k for ax into by minus bx ay. So in this way we can calculate the cross product. Today we have learned how we can calculate magnitude of a vector and scalar and square of a vector. For a square of a vector, suppose a vector a, its square can be written as ax square plus ay square plus az square, and magnitude can be written as ax square plus square root of ax square plus ay square plus az square. We have learned how we can write a in term as a unit vector, a cap equal to a by its magnitude. So axi ayj az cap by ax square ay square by az square, and the resultant vector r for a plus b, the magnitude r equal to a square plus b square twice ab cos theta, and for r equal to a minus of b, magnitude can be written as a square plus b square minus of twice ab cos of theta. So in this way we can calculate these formulas are very essential for calculating numerical problems. Now we take an example, a simple example. Let a and b are two vectors. Here one vector is simply I plus j, and suppose it is twice k, and another vector is minus I plus j minus k. So that is twice j. So minus I plus twice j minus k. Okay. Now we want to calculate the dot product. Dot product a dot b. A dot b. Since we know that a dot b equal to magnitude of a, magnitude of b cos of theta. So in this formula we don't know the value of theta, therefore we cannot calculate by this method. But we also know another formula. This is method 1. Method 1. Another is method 2. Here we know that a dot b is equal to ax bx ay by plus az bz. Here ax equal to simply 1 and bx equal to minus 1 plus ay simply 1 and by equal to 2. Here az equal to minus of 2 and it is minus of 1. So A dot B equal to 1 into minus 1, minus 1, 1 into 2, 2, and minus 2 into minus 1. So it is plus 2. So it is simply 2 plus 2, 4, minus 1, 3. So in this way, in method 2, we can successfully calculate the value of A dot B. So if we calculate A dot B, we can calculate theta also here. Since A dot B equal to 3, okay, now magnitude A equal to, simply we know that x square plus ay square plus az square. So x, here ax equal to simply 1 square, ay square equal to simply 1 square, az equal to minus of 2 whole square. So 1 plus 1 plus minus of 2 into minus of 2, 4. So it is simply root 6. Similarly, angle B, so magnitude of B equal to bx square, by square, bz square, and here bx equal to minus of 1 square, by square equal to 2 square, and bz equal to minus of 1, so minus of 1 whole square. So this is again minus of 1 whole square, minus of 2 square equal to 4, minus of 1 whole square equal to 1. So this is equal to again 6. So we know A and B, magnitude of A and B. So by putting this values, all these values in this formula, we'll get A dot B here. A dot B equal to simply magnitude of A, magnitude of B, cos of theta. So A dot B is here 3, right? And magnitude of A is equal to root over 6. Magnitude of B is also root over 6 and cos of theta. So cos theta is equal to 3 by root 6 into root 6. That means 3 by 6 or equal to half. So we know that for which value of theta, cos theta equal to half, it is theta equal to 60 degree. So in this way we can calculate the angle between these two vectors. Now we will calculate the cross product of two vectors. Now cross product of two vectors. Cross product A cross of B. We know that we have to write it in the determinant form ijk. Here A, x component is 1, y component is 1, and z component is minus 2. For B, x component is minus 1, y component is plus 2, and z component is minus 1. Okay, so we will calculate the value of cross product. For I, we have to ignore this row and 1 into minus 1. So 1 into minus 1, that is simply minus 1. 2 into, again minus 2 into 2. 2 into 2, 2 into minus 2, that is minus of 4. Again we put the from negative sign and write j cap. And here again 1 into minus 1, that is minus 1. Minus 1 into minus 2, that is plus 2, right? Plus k cap. Here for k cap we have to ignore this row. 1 into 2, that is plus 2, minus 1 into minus 1. So it is minus 1 into plus 1, that is minus of 1. So in this way, minus 1 plus 4 minus of j, this is minus 1 minus of 2 plus k, this is 2 plus 1, so 3i, so this is minus 1 minus of 2 minus of 3, minus minus plus, so 3j, and 2 plus 1 plus 3k, 3i, 3 plus 3j plus 3k. Now, so in this way we can calculate the cross product of two vectors. Okay. Now we will calculate the unit vector of A. So calculate A cap. So A cap can be calculated by, this is A, vector A divided by its magnitude. So simply we write on here, in place of A we write I plus j minus of twice k, and here we write magnitude of A is equal to ax square plus ay square plus az square. So ax square is 1 square plus ay square equal to again 1 square, and plus az equal to minus 2 whole square. So square root of 1 plus 4, I plus j minus of twice k, so square root of 6, 1 by root of 6, I plus j minus of twice k. So this is the expression of the unit vector A cap. So we can calculate, similarly you can calculate B by similar method. Now we will calculate resultant of two vector. That means resultant vector of resultant vector of A and B. So here resultant vector R equal to A plus of B. So we have learned how we can add two vectors by its components. In my please watch my previous video where I have explained all these things. Here I j minus of twice k for A plus, and for B minus of I plus twice j minus of k. So here we will add x component of this with x component of this. Here for x component it is 1, for this it is minus 1, plus for j this is 1, and for this it is plus 2, and for k this is minus 2 and this is minus 1. Okay, so k can be written here. Okay, so here 1 minus of 1 equal to 0. So I component, that is x component, is 0. So that 0i means no, in resultant vector no x component will exist. And here it is 3j, 1 plus 2 3j, and this is minus of 2 minus of 1. So this is minus of 3k. So final result is 3j minus of 3k. So R can be calculated by this. And you can calculate the magnitude by simply applying the formula for coordinate vector. by in this way, say r equal to, we know that ax square plus rx square plus ry square plus rz square. Here rx square is equal to 0, so first term will vanish. Then second term ry square is equal to 3 square, and third term, that is that is here, this is the z component, so rz square, that is also minus of 3 square, so it is 9 plus 9, so this is equal to square root of 18, or we can write how 3 root 2, right? Well, you can calculate this result by simply putting the formula what we have learned just in this class. How? In this case, r is equal to square root of a square. So a square plus b square plus twice ab cos theta. So by this formula you also calculate that result. In this case, a square is equal to simply a dot a. So a dot a is equal to I plus j plus k, minus of twice k dot I plus j minus of twice k. So it is simply ax square plus ay square plus az square. You can also use that formula. So we can a square, that is ax square, that is 1 into 1 j y component of here is 1, and also this is 1, so 1, and okay, this and this is minus 2, this is minus 2, so these are 2 plus 2 into 2 4, so this is 6, so a square equal to 6. Similarly, you can calculate, I have already calculated these things in my first numerical, so this b square is also 6, I think. Okay, by b square is also equal to 6 now, and so a equal to, magnitude of a is equal to root 6, b is equal to root 6, and the cos theta I have calculated already. This the angle between them is 60 degree. Okay, cos theta equal to 60 degree, so cos theta is equal to half. Putting all these values in equation here r, you will get the same answer. A square is equal to 6, b square equal to 6, and a into b, root 6 into root 6, cos of theta equal to half. So all these things are the product. So 6 plus root 6 into root 6, that is 6, 6 into half, that is 3. So, and there is a formula mistake. So there is a formula 2. Okay. So these 2 will cancel out. So this is also 6. So it is square root of 18, and again it is 0 2. So in this way you can also calculate magnitude of r. So we have learned all the numerical methods by considering these two vectors a and b. At this point, I want to stop this lecture. Hope you have learned this basic introductions of vectors and scalars through these lectures. If you have any queries, write it down into the comments. And if you like this kind of content, please like the video you can share the video. For if you want more this kind of content, then please subscribe the channel. Thank you.